Hello everybody. The topic which we are doing today, this one is known as AC through a pure inductor. In case of a inductor, you will see that the current it lags behind by pi by 2. So this one, in the derivation, in the last one, we will get the formula as minus pi by 2. So this one is the figure. You can see the figure, and in this figure, this value of V, it is given as V0 of sine omega t, with this one as the inductor. Given below, shown the circuit in which the voltage source, it is given as V equals to V0 of sine omega t, is applied to a pure inductor. This one is the inductor with the zero resistance coil of inductor. This one is the inductor. As the current through the inductor varies, an opposing induced EMF is generated in it, and it is given as minus L di by dt. You don't have to do anything with this one, that the opposing EMF is produced. Just see the formula, or the formula which you will get from here. It is equals to E equals to minus L di by dt. Okay, so this one is the formula. So from here we see that the total value of potential, if you will see over here, so the total value of the potential, there are two potentials. One is V equals to V0 of sine omega t, and another one is E. So the total value is V plus minus of L di by dt, or in simply you have to add these two values, this value and this value. So in this figure you will see that you have to add this value. Formula is minus L di by dt. Another one, you have to add this value. Formula is V, it is equal to V0 of sine omega t, so you have to add these two values. After this, when you will add this one, you will see that the value it is given as V equals to V0 of sine omega t minus L di by dt, it is equivalent to 0. So from here, the value of di, you have to separate the value of di. So it is V 0 sine omega t, it is equal to L di by dt. So the value of di, it is equal to let us solve this one. This one is V0 of sine omega t, it is equal to L di by dt. So from here the value of di, it is equal to V0 upon L of sine omega t with the dt. So from here it is given as di, it is equal to V0 upon L, and this one is sine omega t of dt. Now on integrating both sides, when you will integrate this both sides, the value of di, it is given as I V0 sine omega t. Integration of sine omega t is cos omega t upon omega. Integration of sine omega t, it is equivalent to cos omega t upon omega. So this one will be in this way. The value of I, it is equal to V0 sine omega t is cos omega t upon omega. 1L is initially over here, so the value it is given as I0, it is equal to minus of V0 upon omega L of cos omega t plus C, where C is the constant of integration. This integration constant has a dimension of the current and is independent of the time, since the source has an EMF which oscillate symmetrically about 0. The current is sustained also oscillates symmetrically about 0, so there is no time independent component of the current that exists. So the value of constant that is given as C, it is equal to 0. So in the diagram you will see that now you have to compare this equation. So on comparing this equation, it is given as I equals to minus V0 upon omega L of cos omega t. Now if you will see over here, when you have solved this one, it is given as I equals to V0 upon omega L of cos omega t. You have to compare this one with I is equal to I0 of sine omega t. It means that you have to convert cos omega t into sine omega t, and V0 upon omega L into I0. Now on comparing this one, when you compare this one, the value of the cos omega t, the comparing this one, the value of the cos omega t, it is sine omega t minus pi by 2. So this one is cos theta is equal to sine 90 minus theta, so cos omega t minus pi by 2, and this one it is given as I is equal to V upon R. So this one is V upon R is omega L. Okay, you can see over here it is sine 90 minus theta, please keep in mind. So one minus is there, it is sine 90 minus omega t. One minus is there, so this one is sine omega t minus pi by 2. Sine omega t minus pi by 2, because of the presence of this minus. So from here the last answer which you will get, it is I equals to I0 or V0 upon omega L of sine omega t minus pi by 2. So this one is I is equal to I0 of sine omega t minus pi by 2. Over here the value of I0, it is equal to V0 upon omega L. So from instantaneous value of the current and voltage, we see that the pure inductive circuit, in a pure inductive circuit, the current it lags behind by the phase angle of pi by 2. the it lags behind by the angle of pi by 2. So you can see over here, it lags behind the current, it lags behind by the angle of pi by 2. So this one is minus of pi by 2, it lags behind. So over here this one is the one case, so we have this one. Another one, you can see it lags behind the current, it is lagging behind by the angle of pi by 2, you can see in the diagram. So in case of an inductor, the current, it lags behind by the angle of pi by 2. So the formula which you will get, so these diagrams, these are really very important. And the formula is I is equal to V upon R. So the value of R is equal to omega L. So comparing it with V equals to IR, and the value of R, it is equivalent to omega L. XL is it is known as the reactance of the coil, which represent the effective opposition of the coil to the flow of alternating current. So in case of DC, we know that the XL, it is equal to omega L, and omega it is equal to 2 pi FL. If the value of F is equivalent to 0, so if the value of F is equivalent to 0, so it is equal to 0, so the XL, it is equal to 0, it means that the opposition or the resistance is equivalent to 0. So XL, it is equal to omega L is 0 for the DC, for which omega is 0, and it is increases at the frequency of the current, it increases as the in case of an AC, as 2 pi FL. XL, it is equal to 2 pi FL. Alternating current, it has the value of the frequency, at its changes, it is directly proportional, it also changes. Thank you.